Finally, let's do the last 10 questions from the 2023 A-level paper. We'll look at question 21. The hydrolysis of 3-bromo-3-methyl-hexane produces a mixture of two isomers, so it's isomeric. Okay. Question asks which statement correctly describes this hydrolysis reaction. Okay, so the question already highlighted that it's a hydrolysis reaction involving a tertiary alkyl bromide. Okay, so the students already drew out here, so I'll not draw it out again. So it's delta plus, delta minus. If it involves a tertiary alkyl bromide and it's a hydrolysis reaction, that means that it is likely to be SN1 nature or of SN1 nature. Okay, so that means that inevitably it will form a carbocation, and that will limit our answers to A and B. And then we'll move on to look at whether the carbocation will be attacked by nucleophile or electrophile. Definitely nucleophile, because carbocation is electron deficient at the carbocationic center. So regardless of whether we are looking at is it performing in an acidic medium or is it in an alkaline medium, the nucleophile usually involve either OH minus or H2O with a lone pairs of electrons on oxygen. So definitely the attack is or must be by a nucleophile. So definitely we'll be selecting option A. Okay, yep. Then the rest of option we won't bother to look through them. If you want to, you can. Yeah, but as I mentioned earlier on, with everything in place, you know that tertiary means SN1. SN1 means it goes through a tertiary carbocation. Okay, question 22. We have 1-chloropropane, propanol chloride, and chlorobenzene hydrolyzed in water at different rates. Which statement is correct? If you take a look at your syllabus documents, okay, that is under carboxylic acid derivatives. So I'm just going to show you where it is. Okay, it's over here. Learning objective 11.7F. Okay, you're supposed to explain the relative ease of hydrolysis of acyl chlorides, alkyl chlorides, and aryl chlorides. Okay, this is usually asked again in a structured free response questions. So the answers usually spans around half to 3/4 of a page. But now it's an MCQ. So again, for MCQ, we look out for the best answer and we cross the worst 3 answers out, or the totally irrelevant incorrect answers out. Okay, we take a look at A. Propanol chloride reacts less readily with water. Nonsense. Okay, it should be more readily. Okay, CCl bond is strongest in chlorobenzene, so that showcases partial delocalization of the lone pairs of electrons on chlorine, strengthening the CCl bond. Give it partial double bond character. Maybe okay, unless there's a better answer. If not, we'll choose B. Okay, C, the leaving group Cl minus is most stable in the hydrolysis of propanol chloride. Not true. Doesn't really matter whether is it chloropropane, propanol chloride, or chlorobenzene. If Cl minus can leave, it will have similar stability. So C is out in this case. Okay, so it's incorrect as well. The carbon atom bonded to chlorine is most susceptible to electrophilic attack. Okay, in propanol chloride this is wrong. It should be nucleophilic attack, because the carbonyl carbon has the largest partial positive charge. Okay, yeah, so in this case I will choose B as the most correct answer. Okay, for question 23, we have 10 cubic centimeters of a gaseous hydrocarbon X burns completely with exactly 75 cubic centimeters of oxygen to produce 50 cubic centimeters of CO2. All volumes are measured at the same temperature and pressure. Question asks you which statements about the hydrocarbon are correct. Okay, students work out over here. So again, the ratio is 10, 75, 50. Okay, lowest we divide by 10 throughout, so we get 1, 7.5, and 5. So therefore x is equals to 5. We substitute x is equals to 5 into over here, so we'll get y is equals to 10. Okay, so from here we can easily get the molecular formula of X to be C5H10. That will give it a degree of unsaturation of 1, or we can say that it has 1 double bond equivalent, or we can say that it has 2 less H's than the formula when it's an alkane. Okay, so if it's an alkane, it will be C5H12, 2H less. So 2H less, it could mean two things. Okay, either it exists as a ring, or there is a CC double bond. Okay, so that will make option 1 correct, cyclohexane. Okay, if it exists as a ring or CC double bond, does it mean that it can branch? Of course, the answer is yes, it can branch. It may not be like this only, it can also be like this. So branching is okay. It may decolorizes aqueous bromine in the dark. Okay, is that possible? Yes, if it contains a double bond. Okay, can decolorize aqueous bromine. So this is okay as well. Yeah, so with that choices, we are going to look at option A. So all 1, 2, 3 are correct. Okay. Okay, question 24. In an industrial process, heptane vapor is passed over heated catalyst to make methylbenzene. Okay, so you have this process over here. So under similar condition, which of the C8H18 isomers could give 1,4-dimethyl? The best way to do this question is to number the carbon. Okay, so what I'm going to do now is to just draw it in the correct nice shape, and then I number them accordingly. Okay, so I'm going to do the numbering 1, 2, 3, 4, 5, 6, 7. Okay, and then it's going to get methyl benzene. Okay, like this. I'm going to do exactly what the students did. Okay, and then of course I form a new double bond here. New bond here. Okay, so if I just number, that will be 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to use this strategy to help me solve. Okay, right? Okay, now 1. Okay, how can I draw it out in such a way that I can get 1,4-dimethylbenzene? Yeah, how is it possible? Okay, or is it even possible? Yeah, so I can have a 6-membered ring, something like this. So let's see how I could draw out in the most convincing way. Let me see. Maybe like this, like this, like this, something like that. Okay, let's see if this makes perfect sense. Okay, I'm just going to try it out. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, yep. And then eventually I'm going to get this. Okay, ring, 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 and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, yep. So am I drawing the correct thing? Let me double check. 6, 7. So this is 2. So this is a straight chain with 1, 2, 3, 4. 1, 2, 3, 4. Yeah, correct. Okay, so yeah, 1 is possible. Okay, what about for 2? Okay, so for 2, I think again it should be relatively straightforward. So 2 will look something like this, okay. Yeah, again I'm going to number it 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 2, eventually I'll end up something like this. Okay, then 7, 5, 4, 3, 2, 1, 6, 8. Okay, yeah, so make sure you count them properly so that you don't get missing carbons. Okay, so 2 is also possible. Yeah, 3 is not possible because when I try to join them up, you realize that you will not be able to get 1, 4. Instead, you might end up getting 1, 3. Okay, so again, let me try to draw it out. Okay, just try. Sorry, think it should be like this. Okay, yeah, so I've drawn this out. So let me number it. So there'll be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so if I join 2 and 7, I'm going to end up something like this. Okay, so there will be 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, I'm going to get 1, 3, but the question wanted me to get 1, 4, so this is out. Okay, so 3 is out. Answer will be B. Okay, 1 and 2. Okay. 25. Ethanol chloride reacts with 4-methylphenol. Okay, so 4-methylphenol to give you what do you think it will give you? Ester. Okay. Structured free response, usually you need to convert your phenol to phenoxide to ensure that the reaction goes faster. But this is a MCQ. Okay, so they are not caring about the yield so much. Okay, so again, 4-methylphenol. Okay, so I'm just going to sketch this out. So the phenol is over here, OH. Okay, so ethanol chloride will look something like this. So again, I'm going to join the O to the carbonyl carbon. So I'm going to end up with a compound that will look like this. Okay, yeah, so this portion will be like this, OCOCH3. Okay, yep. Then I think that's it. This is a ketone, so we're not looking at a ketone here, and then the rest are out of the question. Okay, question 26. 3-bromo-4-hydroxycinnamic acid is dissolved in heavy water. It contains a number of hydrogen atoms which can be replaced by deuterium. Okay, so this deuterium exchange, we are only looking at protonic hydrogen, that is hydrogen capable of forming hydrogen bonding. Okay, so if I'm just going to color code them, so it will be here and here. Okay, over here. Okay, so these two are the protonic hydrogens that we are talking about. So total will be 2. Okay, the rest of CHs are not possible. Okay. Question 27. Tripeptide is a molecule made from 3 amino acids which have reacted together in a condensation reaction. Which structures are tripeptides? Okay, I'm just going to highlight them so that it's easier. Okay, with different colors. Orange first. Okay, so I'm going to highlight all the amino acid residues. So this is N2H over here. Okay, so this is one amino acid residue. Okay, another amino acid will be NHCHR prime CO. Okay, the last one I'm not going to highlight because the last one is not an amino acid residue. You notice that it goes something like NH here and then end up with NH2. So this is not an amino acid residue. Yeah, so I'm not going to highlight this. So that means that number 1 is not a tripeptide. Okay, I'm going to continue. H2N, CH2CO. Okay, so that's number 1. Okay, then NHCHR prime CO. This is number 2. Okay, and then number 3, NHCHR double prime CO2H. Okay, yeah, so these are all amino acids residues. Okay, I'm going to continue. So they swap it. This is NHR CH carboxylic acid, so that's okay. Okay, it's just that the N to C terminal is written the other way around. Okay, and then CO CHR prime NH, so that's another amino acid residue. Okay, and then the last one will be CO CHR prime NH2. Okay, so in total 2 of them are dipeptides. Okay, so I'm going to select option D. Okay, 28. Which statements about an hydrogen oxygen fuel cells are correct? Okay, if you can recall, this mostly a recall question, or if you look at your learning objective, it should be under electrochem. Over, I think should be over here. Let me see. Yep, over here. States possible advantages of developing other cells. For example, hydrogen oxygen fuel cell. Improve batteries in terms of smaller size, low mass, higher voltage. Okay, so it's part of a recall question you learn. Okay, so you know that hydrogen oxygen fuel cell does not produce environmentally harmful products. It produces only water, so 1 should be correct. Okay. 2, the fuel cell is very efficient. Majority of the chemical energy is converted into electrical energy. This is correct. Directly what you have learned from your learning objectives. Okay. Then as at one of the cell electrodes, hydrogen molecules release electrons by forming hydrogen ions. Okay, the one you have in your lecture notes happens in an alkaline medium, so it doesn't produce H plus. Okay, instead it produces OH minus. If you perform it in an acidic medium, yeah, so you do end up with H plus. Okay, so it's medium dependent. Any more information you need, you can actually read out more from appropriate text. I think I will just put a link or two below for you to take a look at some useful resources. Okay, so other than that, I think 3 is also correct. We'll be choosing option A. Okay, question 29. Which statements about the standard hydrogen electrodes are correct? Okay, so when a SHE is connected to a half cell with negative standard electrode potential, hydrogen gas is made. Is this correct? If you think of it, you can think of it from the perspective of connecting SHE to, let's say, a zinc 2 zinc half cell. Okay, so you have a data booklet, you can just try to see. So for zinc 2 zinc half cell, it's negative 0.76 volts. Okay, so zinc will displace H plus to give hydrogen gas. Okay, yeah, because zinc is more reducing than H plus. Okay, right? Yeah, so this is true, right? Okay, the standard redox potential of SHE is 1 volt. This is nonsense, because if you measure SHE against SHE, obviously it's going to be 0, right? Because SHE is a standard, so this is nonsense. Okay, the SHE contains dilute sulfuric acid with a concentration of 1 mole per dm cube. This is nonsense as well, because dilute sulfuric acid, you must be very careful, it's a dibasic acid. Okay, so H2SO4, okay, it has 2 equivalent of H plus. So altogether, the concentration of H plus is 2 mole per dm cube. So you should either be using 0.5 mole per dm cube, or you should use 1 mole per dm cube of, let's say, HCl. So again, incorrect. So the answer will be B. Okay, yep. Then 30, I think most of you guys are quite strong in this kind of calculation. So again, we're just going to do it quickly. I have a current, okay, 0.65 ampere, so Q is equals to IT. Okay, passed through to 250 cubic centimeters of 0.2 moles per cube copper 2 sulfates. Anode and cathode are both made of platinum. Okay, so this is deposition of copper to copper, right? I mean reduction of copper to copper. How long will it take for the concentration of copper 2 sulfate to fall to 1.1 mole per dm cube? Okay, so again we take the difference. They want to change in concentration to be 0.1 mole per dm cube. Okay, we can quickly write out Q first. This is equals to 0.65 T. So therefore T is equals to Q divided by 0.65. Okay, then we're going to rewrite Q using number of moles of electron transferred. Okay, and Faraday. Okay, so number of moles of electron transfer. So again, the change in concentration is 0.1. We have 250 cubic centimeters, so that will be 0.025 moles. Okay, and what's going to happen here is that okay, so you notice that all the values, all the options, they don't give you the value. So what they gave you was some sort of a calculation. Okay, so that kind of like make your life easier, because you know that my Q is equal to number of moles of electron transfer, right? So that will be the volume I need to convert to dm cube. Okay, I need to multiply by 0.1 because that's 0.2 minus 0.1, so that will be 0.1. Okay, and to deposit, for every 1 mole of copper deposited, 2 moles of electron is transferred. I need to multiply electron by 2. Okay, then I need to multiply by Faraday constant, that is 96500. Essentially that's 9.65 times 10 to the power of 4. Look through all the list. I'm just going to highlight. Okay, you see which one fits the bill. So we have 250 divided by 1000. Okay, then 0.1, okay, 2, and then 96500, and then over here 0.65. Okay, right, so that will give me the time in seconds. Okay, so that's it. Yeah, the rest are all incorrect. I don't think we need to discuss them any further. Okay, so unless if you have questions, you may put them down in the comments below. If not, that will be the end of the review for 2023 paper 1.